Okay. Welcome back. So we're going to start again and try to keep the 7 minutes late we have and not more. So we had to swap two presentations. The program that is online reflects that. So Dia Majoub, who's in the back actually, will be doing his presentation on Friday morning. So he counts on you to be there Friday morning, just after the breakfast. And Peter is going to do the next presentation on Virus Tracker. And Peter, you have the floor.
Thank you. Okay, perfect. Thank you. So we have developed a large sinkhole system, and we have heard today a lot about sinkholes, and it's very interesting for myself to be here because we have also like sinkholes about Zeus Game Over and about other Trojans mentioned earlier about this Havex and other campaigns. And having a sinkhole is very easy if you have one, and if you just have to manage a few sinkholes. You can just register a free domain that is being used by a Trojan to send data to or to get commands from. And if you register that domain and point it to your server, you can see who is infected and you can get statistics out of that. And a lot of companies are doing that, like Kaspersky. For all the reports they publish, they try to sinkhole and register available domains to create all the statistics. But they usually don't do anything further with the data. Sometimes they share it in a certain network, but often they just like run the sinkhole a few days, get some nice graphs, and then do anything. And we started to build our business model around it. We started Virus Tracker in September 2012, and we want to have statistics and seeing the infections over a long time, not just for like 1 week, but like as long as possible. So for example, we have Zeus Game Over since the very early days. We have a full graph of Zeus Game Over since 2 years, and you can pull out a lot of interesting facts and things of the data, and it's very interesting also to look at the graphs. Like for Zeus Game Over, we can see when was the takedown or when did something happen. And we have many sinkholes. We have over 7,000 domains pointing to our server, and we don't only implement the sinkholes for the HTTP Trojans, but also for peer-to-peer Trojans. So we write peer-to-peer crawlers that are active, that crawl in the network, get all infections and store that also in the database. And our approach is a little bit different than the one from Anubis Networks. We don't analyze like network traffic and find new domains. Instead, we go to sites like VirusTotal, Threat Expert. We get the data and we check the command and controls, and we see if they're available or not, and sinkhole them in case. So we follow a slightly different approach, and we store it all in a database. And there's a lot of stuff going on in the back about automation of everything and about classifying the data and also filtering out false positives. As we heard today, we see many false positives from researchers, from bots, Google bots and other ones, and also from stuff like domain tools and other ones. So we work a lot on filtering those out, and what we do is to automate it all, because we wouldn't have the time to like manually register every single domain, but we have completely automated. We use APIs for that stuff and have it completely automated, that we only need one domain and we say, okay, it's this Trojan, and sinkhole it, and then it's automatically added to the system, and we can immediately pull off the data. And we started initially because of banking Trojans. When we started it 2 years ago, we just wanted to know how big are the banking Trojans, what countries are they affecting, can we get any other data out of that? So we started just by sinkholing Zeus Game Over and Multibanker and others, and then it became more and more, and then over the time we said, okay, we will add all Trojans that we can get, so also small ones, small rats, and some APTs, and also of course all the bigger ones, Configure, Celity, and Zero Access, and all the other ones. So, and with the data we want to generate statistics, and we want to inform companies that are infected, and based on our data we can say everyone is infected, from the private person to bigger companies, multinational companies, also governments. We even have infections at the CIA, and so yeah, everyone is being targeted. And we share that data to customers, and for free also to CERTs. We give it CERT EU and CERT Canada, and they use the data to detect infections in their own network and send it to the organizations so they can remove the infection. So we see always an increase, but the increase is not because there are more Trojans, it's because we have more coverage. We tried to add domains as good as we can. So first we were just going after the bigger botnets, and then also after the smaller one. And when we see some report about a new APT, then we immediately check for the domains and we add it to the system. And we have APTs like Stuxnet, Flame, and other ones that are popular right October, and we get some nice interesting data. And for Stuxnet, I'm later showing a demo of the real data. There's still a few infections active, not many, just like a few connections per day, but they still report to the server. So when running such a large sinkhole system, then you face a lot of challenges. You have technical challenges, you see a lot of data, we see more than 3 million machines every day, and some bots are really badly programmed. They connect every second or every few milliseconds and just always contact the server. So initially when we just started it as a proof of concept, we were just running it on my laptop, and it was just like a small MySQL database and based on Apache. But now we changed it. It's all our own proprietary code. So the HTTP sinkhole, the server is purely written all in C, and with that we can handle all the millions of requests every day. And we only store 1 request per IP address per day. Otherwise it would be too much for the database. And we have right now more than 1 billion requests in total in the database, and it's getting more and more. And it's about 400 gigabytes of data on the hard disk, the database. And we try to minimize it. So we face many challenges, technical, legal, financial ones. One of the current ones was takedown of some domains. There were domains seized by Microsoft when they filed some court orderings for SUSE and Citadel. So they got the list from different sources and just gave it all to the court and took over all the domains, including some we had. And also during the SUSE game over takedown, the FBI seized our domains and pointed to their servers. But we have, on all of the domains, it says our company name. So everyone checking out the domain, the whose information, sees that it's a legitimate sinkhole by us. And same as the seizures, we have sometimes complaints from people sent to the domain registry or registrar, or to our hosting provider, or to ourselves. And then sometimes domains get blocked, but usually when we send them an email and say, hey, this is a sinkhole, it's passive, we don't send out any commands, we use it to get statistics and we share it with the security industry, then they always unblock it. So that's not that big of a problem. And domain cost is relevant for us. We spend about 700 to 1,000 euro per month on domains, and we have to repurchase them all the time. Like for Configure, we have to repurchase 4 domains every day. For SUSE Game Over, we have to repurchase them for the SUSE Game Over 1 every week. And so a lot of money goes for just buying the domains. And not always they are available. They're like different, the Trojans, sometimes they have backup domains that are free, sometimes they just expire, often at EGA, and that's how we acquire the domains. And for scaling, what we do is we have some load balancing, and we have like all of our servers are distributed, some in the US, some in Germany, even in Prague. In my home, I'm running my peer-to-peer crawler, and it works pretty well. I can connect to even more than 1 billion machine just from my home internet connection, 40 megabit, and that works pretty well. Another challenge is we have many different botnets, different types, different sizes. Not all are having HTTP as a protocol, so we recently developed also a TCP sinkhole. And for those that have the HTTP protocol, sometimes the Trojans have additional info that might be interesting, or sometimes they send something wrong, or sometimes they do stuff they shouldn't do. So that was an issue, and what we did is we managed to, of all the different types of Trojans, and even for the peer-to-peer stuff, we store it always as the same format in the infection record. And then there's some identification issues. When we see the IP address, we can use gRP databases to get the organization, but often that information is wrong or outdated, so we don't always know who is really infected. We see always the internet service provider, and for bigger companies we also see the company name, but for smaller companies or private people we only see the internet service provider. And for example, as mentioned, we only store 1 IP address per day, 1 infection per IP. And for mobile infections, we recently added about 30 Android botnets. There is a problem because the mobile phone, the data providers, they heavily use NAT. So if there are 1,000 infections behind one IP address, then we only see one storing in database. We tried to deactivate that for mobile, but there are botnets that really every second connect, so that would spam the database. So we turned it off immediately. And part of what we do is we reverse all the algorithms of the Trojans. We reverse the peer-to-peer algorithms and the functionality, and also the DGAs, and we implement them ourselves, so we can always register the domains in advance. So for finding new domains to sinkhole, we use automated stuff also for getting the reports from sort of expert total hash, or we look it up on VirusTotal, and it's a mix of automation and manual analysis. I'm myself analyzing the Trojans, and then when I see them, I add them to the list to sinkhole. And we also what's also very important is legal considerations. As we are dealing with very sensitive data, we have to have a strong policy, and what we do is only store like meta information, and we don't even record or we don't even analyze any data that gets sent along as in a post request. So we don't store like passwords or anything like that, credit cards. Some other companies do, but we don't. And recently, a few days ago, there was a DDoS attack against Virus Tracker, which I have in another slide, and that one wasn't really a problem, but I will get into details later. So the big solution to all these problems is optimization. We're a very small company, 4 people. We can't do it all manually, and so we automate it all. We have, like, with one click, we can add a new botnet to the system, and then it sets up the DNS records, it sets it up in a database, and it's doing all automatically, and it even generates like the files to download on the server and shares the data. And what we want to do, and what we are doing already and want to extend, is sharing of our data. We send some data to certs and security companies, and we want to share it with others. So if anyone is interested, just contact me and we can provide you with some good infection data, and basically doing similar stuff what the Shadow Server Foundation is doing. So as mentioned, we only store the meta information. We don't store any private details about that. And one big thing that we do is the false positive detection. For a big botnet like Configure, it doesn't matter if you have in the statistics, if you have 1 million infections per day or if you have 1,000,005 infections, no one cares. But for APTs, it's very important to filter out all the researchers and all the automated system sandboxes, bots like Google stuff and domain checkers and WebSense and other ones, because they falsify your statistics, and it's bad if you say, okay, like so many infections are coming from the US, while they're all just researchers. And what we do is when we add domains to our system, we also store the expected path. So if a Trojan is always checking in at /gate.php, then we check it at the sinkhole server. Is it really checking in at gate.php or something else? And if it's not at the expected one, we set the record to non-thread, but we still store it in the database. And we also use the user agent to filter out like Googlebot and other ones. And also we have a hard-coded list of IP addresses that we know that are like different sandboxes, like Threat Expert and other ones. What we did was we were submitting one sample that reported back to us, and we were submitting it on VirusTotal and on Threat Expert, and the sample was contacting our server, so we know which IP addresses they have and they use for their analysis systems, and then we can just map them against our data and filter them out. For Stuxnet, for example, it's like 4 or 5 infections per day and like 50 or more false positives per day. And what we do is we only store like the relevant information, like we store the IP address, we store the domain identifier, and maybe some part of the user agent, but we don't store like the entire HTTP request, and we also don't store the GUIP data in the database. We do it on the fly. Once someone exports the data, downloads it, we add the GUIP information. And what we are also doing right now is making historical GUIP databases as an array to have correct GUIP information, because over the time, over now 2 years, there are many IP ranges already reassigned. And another thing that we do is we have filters, so you can just download it for your ASN or IP range, and you can also set alerts to get an SMS in real time if there's a new infection coming. And also we developed one application where you can download the data and inspect it manually. So we have peer-to-peer crawlers. I wrote them myself for all the major peer-to-peer Trojans. There's 0xS1, 2, SUSE-Schema 1 Sality. 0xS1 is TCP based, which is not performant at all and creates a lot of problems if you have if you want to connect to many infections. Right now there are like only 10,000 machines from 0xS, so that's not a big issue. But if it were bigger, then it would be a problem to keep like 100,000 TCP connections open at the same time. Would be a big deal. For 0xS2, SUSE-Schema 1 Sality, there were up to more than 1 million peers in total. And they're all the other ones, they're UDP based, so that's not a big problem. We have I have written the crawler, and we have queues where the requests are coming in and are handled, serialized, which works really well. And I'm programming the stuff just in C and running on my Windows server, and works really good. One problem is only when you analyze some very old Trojan like 0xS1, which is from 2011. And I think in late 2011 they created 0xS2. If you have a very old sample, it doesn't connect to the peer-to-peer network because the hard-coded peer list, which is only like 10 peers or maybe 50 peers, they are all dead. So you need to find an initial peer to hook into the peer-to-peer network. What you can do is you can do port scanning. We got one of our servers suspended because we scanned like nearly the entire internet for like one open port. And what you can also do is you rely on other people that are a few other people, like 4 or 5, also doing peer-to-peer crawlers and generating statistics. So you can ask them and ask like, hey, give me please some initial IP. And here you can see the program is a little, but this is like what it looks like to me when it's running, and it's basically all the time crawling, and within 10 minutes I'm recontacting every peer in the peer-to-peer network and asking for its neighbors. So always constantly enumerating the peers, and once there's a new peer, I'm sending it to the database. We have 2 crawlers, one in the US and one out of my apartment. And it's really nice that the Telefonica didn't yet shut down my internet line, because someone would think it would look suspicious if you have 1 million UDP packets within 10 minutes all the time. And it works, we run it all on physical machines and just normal hardware, nothing really cost expensive. It's enough to have like 8 or 16 gigabytes for it. And only after you have like more than 1 million peers, things are getting slow also for the network devices, and the network stack, it gets exhausted. And then running more than 1 million peers at the same time from one internet connection from one machine is not nice. And for Windows, it's really good. You can set all the relevant limits, and also there are some kernel commands that you can set Windows to set the drop time faster and all this stuff. So that works pretty well, and the network stack of Windows, from my experience, is really good. Works without any problems. So here are the statistics. That was back in April. Right now they are much smaller. They are all 0xS1 and 2 are abandoned. There was a takedown by Microsoft in December. SUSE Game Over was also taken down, and we have seen in total about 140,000 infections of SUSE per day a couple of months ago, and about 70 to 100,000 peers. And we classify them as active, inactive, and supernode. Active means, well, supernode means you can contact the peer from the outside. That means it has either port forwarding enabled, or it doesn't have a net or a firewall. Active means if the peer contacts us, but we can't reach it because of a firewall or because of net. Inactive means if we ask a peer for a peer list and we see new infections, we contact them, but we never have any direct contact with them. So they are being shared among the peer lists, but they're not actively participating. And for 0xS1, we see inactive peers floating around because they're all sharing all the time the peer list with each other. So we still see infections back from 2011. Like old infections that used to be there but not active anymore, and they still share the peer list. And for 0xS1, it was a TCP. It was a TCP protocol, which was really bad and really sucked. And for 0xS2, the protocol was really nice. It was very flat. It was a very small header. You had like 3-4 basic commands. very easy to implement, highly scalable. For SUSE Game Over, they had they switched the algorithm and they strengthened it a couple of times because of the disruption attempts by the law enforcement. So they implemented like some that the attacks were to isolate the clients. So and doing basically an isolation or fake peer injection. And what the criminals did was they, for example, they made a protection that you can only have like one IP in the 22 range, I think. So you can't like spam them all, and if the peer is not active, then it drops it basically very fast. One thing that is implemented in Celidity but not the others is they have a reputation basis. So every time the peer contacts another peer, it hires a count, and then it's being shared preferably to other peers. So there are some protections against crawling, but you can get around them. The thing about SUSE Game Over is that the protections are really good, but I did some way around that, and I managed to still crawl the entire network, but it was very slow, and it was only like they do some DHT similar stuff, and this is basically like the defense they have, and they do some DHT stuff. So if you contact a peer, you need to know the ID of the peer, and you need it as encryption key. And they did some good protection stuff. And if you ask a peer for the neighbors, then it won't share all neighbors. It will only share them which are close to your ID, which makes it more difficult. But you can get around if you constantly change your own bot ID, and if you use several IP addresses, then you can get your way around that. And the SUSE Game Over peer-to-peer network is still active, but there are now only like maybe not even a few hundred infections. But yeah, nothing big anymore. So the other thing that we do is the domain prediction, and it's very easy when you run a sample in a sandbox and you have Wireshark attached to it, and then you quickly see, okay, this is a DGA and this is the one of SUSE Game Over, and we implemented algorithm. It's usually very easy when you have the malware running in a system and you just do a crash dump of ExploreX if it's injected there, and you analyze it in IDA and you have it live, and you just match all the stuff. You can find the DJ usually very fast, and using IDA it's usually very simple. If you know where to look for, you can quickly find it, and then use Hexris decompiler, and then you have the algorithm, and then you can predict the domains. And we publish all the domains for the future, for the next week, on the blacklist, and we sinkhole them and register them. And there are a couple of other companies doing it, but they usually they only take a look at one Trojan like for a couple of weeks, but not like forever. And we want to always watch them. We want to know all the time how big is the botnet, if there are any changes, if there are new infections, and want to have all the data in the database. There are some anti-sinkholing techniques. Some are used. For example, the criminals could blacklist the IP address of our sinkhole server, then we wouldn't see the connection anymore. They could also just, if they know, they could blacklist our domain. That happened with Multibanker. We always sinkhole them, and then they sent to, using the real command and control server, they sent a blacklist command to all their infections, which contained our domains, which was very easy for us to bypass. We just bought new domains. They didn't even they didn't block the IP address, but they blocked the domain. For Cinema, what they did was they were blocking the IP address, and it was very effective, and that was really annoying. And I was already thinking about setting up some bigger infrastructure, having some VPSs and having some VPNs to always have different IP addresses, because they were always like, anytime I change the IP address, they just send out a message to all the peers, to all the infections to blacklist our IP address. So we only saw the infections for like a few hours or a day, and they already blacklisted our server. But for some reason, the Cineval botnet was also abandoned. And some sinkholes of other companies, mine isn't, but some put X-sinkhole, malware sinkhole into the HTTP header. And there's one Trojan which also checks for that. And for peer-to-peer, if you have like very strict limitations also about like packet size and the count of how often it can contact you, then you can have a really strong defense against peer-to-peer injection or some other attacks, disruption. And what you could do with peer-to-peer, and no one ever has done, you could use a peer-to-peer network for an attack. If you not own it, you could like tell all the peers in the network, you could say, oh, contact this new peer, and then like for Celidity or for SUSE Game Over, then a couple of 100,000 machines would always try to contact that peer. So that would also be a possible DDoS attack for someone not owning the botnet. And some peer-to-peer Trojan, or there's the idea that you have backup lists. Once, like if you're isolated, then you have some other initial peer lists, or you have some fallback algorithms. Like with SUSE Game Over, it was falling back to the DGA if it's isolated, and then from the DGA it contacted the command and control server, and then it got again a new list of real peers. So this is how it got back into the network. And some have like backdoors, like zero access to had like a command that you can send to the peer directly a message and say like add this new peer, one single peer, and this has to be signed. So even if they're all disrupted, if they're still active, and if the criminal knows the IP addresses, then they can just send them all a fresh list of IPs to connect to. SUSE Game Over didn't have such a protection. And we had a couple of days ago, we were under DDoS. It was 1 gigabit attack. You can see here, you can see always the wave during the day, the connections. And we have about normally like 30 megabits of sinkhole traffic in and out. And then it was more than 1 gigabit per second, and the data center shut the server down as a protection. Well, they null routed the IP address. They say, I am responsible for basically the traffic, and they're null routing it. And then after 2 hours, they enabled the IP address again, and then the attack stopped already. So I unfortunately don't have any PCAPs of it. I only have the information that were given by the data center to me. And it was a mix of UDP, TCP, and ICMP DDoS. And there was only, in this list, there's only one TCP. It's a Turkish IP address, and the IP address is in Virus Tracker as a Celidity infection. So maybe the Celidity people used their botnet to attack Virus Tracker. There was one interesting IP address which belongs to a military government network, but it's probably spoofed. I don't think that government would DDoS my server from their IP range. I don't think that would happen. So yeah, it's probably spoofed, which is very easy with UDP. So as an example of our data, there's Stuxnet, and once you know the command and control servers, which is my premierfootball.com and todaysfootball.com, once you know these domains, you can try to acquire them. For one domain, we caught it because it was expired. We have a domain catching system automatically. We have like a list of domains that are interesting for us, and the domain catching system will register them once they become available. We also, on the other one, we were paying about $900 from some platform. So when you check out the domain, then you can clearly see that it's our server. And here's like some data preview, but I'm going to show you some real life data. Let's see if that's good of size. So I have downloaded here the data from November 1 till today. And as you can see here, all the gray ones, they're all false positives. So there are a lot of false positives, for example, from WebSense, because they always constantly check all the domains and always access them. And there are only very few real infections. So if we show only the malicious ones, then you can see these are the ones that are still infected. And it's interesting for Stuxnet that it only contacts the server. I think like, I haven't checked it out, but it's only like every few days or weeks. So it's not like other botnets which always like try to communicate with the CNC like every few minutes or every few hours. So this one like really goes under the radar, or attempts to go under the radar. And we do here, the good thing about detecting false positives is here we check for the request path. So here like they're all just accessing slash, and the real one is slash index.php with some other data. I published like a few months ago a report, a blog post about it, and it was a lot then copied into Iranian media, online media, and I got some very suspicious emails coming from Iran following that information, also one from CERT Iran, and it was very interesting because there was like no name of anyone there in the signature. There was like no name, there was no phone, no anything, but they all asked like for more information for that. But yeah, so here's some information. So you can only see like up to 5 infections per day of Stuxnet still connect to our server. And you can see most are in Iran, and then there's India, Saudi Arabia, and others. And here there's like, for example, one false positive, I think, somewhere, which we didn't filter out. So where was it? Here, this one with the XXX, that was probably a researcher, which wasn't detected. And if you show it on the map, oh, I don't have internet here. So that's, so that was the Stuxnet data. And recently, like a few weeks ago, we started to also sinkhole mobile botnets, and basically with our system, you can just sinkhole anything independent from the platform that the infection is running on. So we just took all the reports about the mobile Trojans, and we got all the CNCs, and then we just sinkhole them all. And the biggest one is mobile repain, and we see altogether, yeah, about 15,000 infections per day. And we have 3 BlackBerry botnets out of APT Red October. And there was one APT Red October infection earlier this year at one very important government organization, which was interesting. And there's one Symbian botnet that shares the same domain with an Android botnet. So the criminals made the Trojan, they developed it for both Android and Symbian. You can see here like some geographical distribution, but this is not a real heat map. It shows like just the infections pointed on. And one point could be even like 1,000 infections because our QIP database isn't, it's not perfect. So among the data that we see is this data above is sent by the Trojan in the GET request usually. So they send us like the EMI, the IMSI, and sometimes even the MAC address and screen size and stuff. And we extract the EMI and store it also in the database. And in some cases, the network service provider also adds some fields. It's always in the media then when they do that. They add like in the HTTP header some tracking cookie, basically like a tracking identifier that they're placing there. And if you go from your phone on any website, this website will get this tracking identifier, and they're using it so that third-party companies that are partners of the network provider, they can basically identify you and give you like a better service, like more ads specified to you. And we are not analyzing those such specific tracking identifiers. This is one example of the data that we see. So this is like a real infection. And here you can see like from the user agent, we can already tell what device model it is. And then from the Trojan, it sends all kinds of data along with it. When it's interesting to always take a look of a very long time of a botnet and see like how are the infections going, increasing or decreasing. And for here we have zero access and configure both abandoned. And there's still like, there used to be over 1.6 million infections of configure. And there used to be also many infections of zero access, and there was the takedown in December. And you can clearly see since the takedown, infections are going down and down and down. And that's because people reinstall operating systems or get new systems, or the Trojan gets removed from antivirus. So with this data, you could basically say, like, okay, when is the botnet really dead, or when is it really irrelevant? And what we do with all the data, or what we try to do, is gathering statistics, gathering intelligence, seeing who is infected. Like for the banking Trojans, it's important to see, okay, this banking Trojan is targeting only Germany or Netherlands. And very often the banking Trojans only attack specific countries because they can only cash out from specific banks within the countries. So they are not interested in infecting everyone. And we see a big change since the past years. The botnet people, they don't want to infect like everyone. They don't want to have millions of infections because they don't need millions of infections. They only need a few hundred, let's say in Germany, to steal the money from a bank. And if you have a few hundred infections with users that have online banking at the specific bank, then it's still a lot of money, and even more money than they cash out. And they try to stay under the radar. Like multibank, for example, they really try to stay on the radar by just infecting a few hundred machines in Germany, and then antiviruses like Symantec, they didn't detect the sample. They didn't even had the samples because like only a few hundred were infected, and so they're trying now more and more and more, at least according to our data and according to our research, they're trying to stay under the radar and not infect like the old botnets that configure millions of machines, but instead only a few, and try to exploit them specifically. So we have, as mentioned earlier, like we are also generating like also files already on the server that the one program I was showing you can download, so we can immediately look up the infections and browse them and check for any interesting stuff for stuff for our report. And I'm going to show you some more data. Where's the mouse? So here, for example, we have SUSE Game Over, and it was growing and growing and growing, and then we added like it was in January we added the peer-to-peer crawler and botnet. So we crawled the botnet and added it as well, and then on the top we had seen about 140,000 infections per day. And here you can see clearly it was in May. Here they started the takedown, and then it went all down. And here the one spikes. There are two new versions of SUSE Game Over. The SUSE Game Over, we named it SUSE Game Over version 3 and 3.1. And they only have a few thousand infections, but they're still active. And interestingly, one of the SUSE Game Over botnets is active majorly only in Ukraine and some countries around. And the other SUSE Game Over botnet is majorly only active in the US. So that was a very interesting to observe. And we can have a look here like at configure again. So here you can, it's always going down and down and down. So like within 1 year, basically like 500,000 machines were not infected anymore or cleaned. Oh, let's have a look at mobile. Yeah, and it's always like, usually the botnets, they are always slowly going down, more or less automatically, because the infections get removed, and unless the criminals are infecting new machines. So we can also have a look here let's look at mobile botnets and not APT ones. Or actually we can. So we can have a look at statistics about the APT. It's like I think 1,500 infections per day. So here are like all APTs that we're tracking, and we see roughly 900 to 1,000 infections per day. And the most targeted country of APTs is Iran, followed by US, Pakistan, China, and Spain, then and some others in Russian, Germany. So that's basically it. Just wanted to give you some broad introduction into the work we're doing and the stuff we're doing. And we spend a lot of time reversing all the different Trojans and implementing the algorithms so we can add them automatically. And all the systems are just working automatically for us and catching new domains. And we're trying now we are going to publish a public API that anyone can use to get the infection records and get the statistics out of it, so people can use it, you can use it, and I want you to use it, I want to share the data. There's nothing worse than if someone has a sample or data and they're just sitting on a huge pile of data, and we're sitting on a huge pile of data, and you have to do something with the data and share it. And I don't think there's, like for example for samples, there's no such thing as a private sample. I think you should always share the sample, and you don't like own information, and you should share it and help others. And I don't want to like reinvent the wheel, or I don't want others to reinvent the wheel. So this is also why I'm here, and why I want to encourage anyone to also use our data to remove infections and get some statistical information out of it, and just create awareness out of it. Thank you. Any questions?
Questions?
Hi, I have one. Uh, do you use anything to register other than making sure that your company name is on everything that you sinkhole? Is there any other source, like sinkhole registry, that you use so that people can look up those IPs and domains?
Um, well, you can check for our domain name. Well, I mean, you can check for the email. We have the email address in, and you can always do a reverse lookup and find all of our domains, and they're all pointing to basically like the same server, same IP range, so you can always verify that it's us. I mean, it never happened so far that anyone tried to register a malicious domain under our name. Could happen, didn't yet. Maybe we see that.
But is there any central source where, say, anyone who is looking at IPs and domains could, because you may sinkhole some of them, another company may sinkhole a different group. It'd be great if we had sort of one single repository.
Yeah, I agree. I agree, and I want to like make Mars Tracker more open and share the data, because right now a lot of different companies are like doing similar stuff like that, and they keep the data only to themselves or only to a very private, closed network. And that's true, and that's a big issue. Like for SUS Game Over, there were like 4, 5, 6, 7 companies sinkholing the same botnet, not sharing the data with each other, and all reinventing the wheel and doing it again and again. And that's something that has to be addressed definitely in the future.
I've heard of some projects, but I've tried to reach out to people that are running them, and I never get anything back. So I don't know if they're actually
Yeah,
live or
it's
not.
very it's tough. Often you send an email out and you don't get anything back. Happens to me as well. Yeah.
Okay.
On that last point, I think abuse.ch are setting something up.
Yeah, I mean, abuse.ch, they have, they're working a lot with Shadow Server, and they have a lot of sinkholes. And what they also do, what I don't do, is when they find some, well, in the tracker, they tell it the registry, and they also ask them to point the domain to their servers for the sinkholing stuff. We don't have that, but yeah.
Just one side note, there is a sinkhole registry. Well, it's not sinkhole registry, it's called a sinkhole database. You can register there if you are a sinkhole operator, or if you are a law enforcement agency or an AV vendor. And the cool thing is, if you are a sinkhole operator, you can register your sinkhole and define who should be able to see your sinkhole IP address. And if a law enforcement officer, for example, wants to initiate a takedown or sizing of a certain IP address, he can just go to the sinkhole database and enter the IP address, and he should then get intel if IP address.
Where's that?
I'm sorry.
Where's that?
It's HTTPS //syncdb for sinkhole database.abuse.ch. You will have to register, and I have to approve your sign up, but it's free, of course.
What I'm using is I have like a list of known sinkholes, and always before I do some action on some domains, I always check, okay, who's owning the domain, so they don't report legitimate sinkholes. So I have like a wide list of known IP addresses and also name servers of sinkholes. We have like, there are around like 15 to 20 organizations actively doing sinkholing.
Last question. Hello. In your slides, you talked about the APTs targeting specific countries. How do you see them, that they target these countries?
We do a lookup of the IP addresses and in a GUIP database, and then we see out of what country.
Okay, it's a single information where they come from.
Yeah. And then we generate the statistics and see where it's spreading.
Okay, thank you, Peter.
Thank you.
Karine. Nick, does someone have an adapter for the Mac? Did you have one or? Non, c'est bon, il y en a un devant. Merci. C'est magique. Comme je vois pas. Je connais pas.
Ok, ça marche.
Okay. So we actually did ask a lot of legal questions.